All right, so we talked about the 45, 45, 90 special right triangles. Now we're going to look at the other one. This is a 30, 60, 90 right triangle. Okay, so the 30, 60, 90 comes from an equilateral triangle. So equilateral triangle ABC, and say we just have side lengths S. The altitude is going to be drawn inside of this. Remember, your altitude goes from your vertex perpendicular with the other side. So we're going to have a 90-degree angle over here. When we have two perpendicular lines, we're going to have all 90-degree angles. So whenever we look at this, we're going to label the angle measurements for both these two triangles that we have now. They will be congruent. Here, obviously, we have that 90 from our right angle. And then in our equilateral triangle, we need to remember is we learned that your angle measurements of an equilateral triangle are all the same, and they're all 60 degrees. So over here, we have the 60 degrees and 60 degrees. Now, the angle up top is not 60 anymore because we have that altitude drawn. When you have an altitude drawn in an equilateral triangle, you're bisecting this angle up here, meaning this will now become a 30 degrees and 30 degrees. And this is where we get that 30, 60, 90 triangle. 30 degrees, 60 degrees, 90 degrees. When we take a look at what's going on with the labeling of our sides, like we had A, and A square root of 2 on the 45, it's going to change up a little bit. Okay? And at 30, 60, 90, the hypotenuse is now 2 times as long as the shorter leg. And we'll talk about that here in a minute. The shorter leg, we're going to multiply it by 2 and get our hypotenuse. The longer leg is now the square root of 3 times as long as the shorter leg. So the other one we had square root of 2, here we have square root of 3. Remembering back when we talked about how to find the longest and shortest sides, the shortest side is always across from the shortest or the smallest angle. Smallest across from the smallest. So here we have 30 degrees. Across from the 30 degrees is our smallest side, which is going to be that A. Across from our larger angle here, 60, we're going to have that the longer leg is square root of 3 times that shorter leg. So across from the 60 is going to be A times the square root of 3. So now we have A square root of 3. And the radical is no longer on the hypotenuse. Then across from your 90-degree angle, your hypotenuse is 2 times the shorter leg, 2A. So this is the pattern that you need to see so that we can, when we label our triangles, we're using A square root of 3, 2A. And make sure that we're putting them in the correct spots as well. Always refer back to this picture so we don't put things in the wrong places. So we take a look at the first example here. We're going to find the length of LM and the length of MN. So let's go ahead and make sure everything is labeled correctly here. We have the 60 degrees. So when we have the 90 and 60, automatically they're only going to give you the 90 and then one other angle measurement. You have to automatically know what the other one's going to be. It is a 30, 60, 90 triangle. Okay? Now, as we discussed, let's go ahead and label our A square root of 3, and 2A. Across from the 30, the smallest, is always going to be A. Across from the 60 is going to be that radical A square root of 3. And then across your 90, your hypotenuse is 2A. So what we're going to do here is we're first going to circle the measurement and the label right here so we know what's equal. And we need to solve for A so that we can find MN. Okay? So we set these equal to each other. 2A is equal to 14. And just like if it was 2x equals 14, we solve for A simply just by dividing both sides by 2. And then A is going to equal 7. So MN over here, we'll say therefore MN is equal to 7. Now when you take a look at LM, okay, is equal to A square root of 3. Well, we know what A is now, so we're going to remove A, and just have the square root of 3, and we're going to plug in what A was. A was 7, so we're going to substitute it in, giving us LM, didn't leave myself much room there, is equal to 7 square root of 3. Okay? So this is one of the simpler ones where I give you an easy number to divide by 2 for that hypotenuse. Let's take a look at our next example. we're going to find the two missing sides, okay, LM right here and LN. Let's go ahead and label everything. We have our 60 and our 90, so we know this other one's going to be 30. Across from our 30, we have A. Across from our 60, we have A square root of 3. And across from our 90 is the 2A, following that pattern of this triangle up here that's barely still on the screen. Now, we have A. So A is going to be equal to 2 square root of 5. So let's go ahead and document that here. A is equal to 2 square root of 5. To find LM, okay, our other leg, let's take a look at what happens here. LM is A square root of 3. So we're going to do the exact same thing we did over here. We're going to substitute in for A, but A is going to be a little different this time. So we're going to remove A, and we're going to plug in what A is, that 2 square root of 5. And just like we looked at with the 45, 45, 90, if we wind up in this case, we need to see here that we have two radicals that have to be multiplied together. The whole number 2 has nothing, okay? But then we take the square root of 5 times the square root of 3, and we get the square root of 15, because 5 times 3 gives me 15. So 15, square root of 15 is already simplified, because if you factor it out, you're getting 5 and 3. There are no partners. So you're done. And here is LM. Now, to find LN, LN is that 2A. So here we have 2A. Again, we're going to remove A, and we're going to substitute in for what A is, 2 square root of 5. Now, this is different than the last one because the last one we had radicals to multiply. Now we have whole numbers to multiply. So we multiply our two whole numbers together, we get 4. There's no other radical to multiply the square root of 5 by, so we just bring it down. And we get 4 square root of 5. All right, let's take a look at a few more other problems here. All right, with our next one, let's go ahead and label everything. We have a 90 and 60. Let's go ahead and label in our 30 degree. Across from your 30 degrees is A. Across from your 60 degrees is A square root of 3. And across from your 90 is 2A. And please make sure that you're pausing and going and writing it, rewinding if you need to hear it again. We're going to circle the measurement that we have. We have A square root of 3. It's going to be equal to 8. So to find A, or MN down here, we have to solve for A. We did this at the 45, 45, 90. We set these equal to each other. Okay? So to find MN first, finding A, we need to set A square root of 3 equal to 8. The only difference now is we have the square root of 3 instead of square root of 2, but the process is still exactly the same. Get A by itself. So we divide both sides by the square root of 3 so that we're left with just A. And again, we have that situation where we have a radical in the bottom. It's a no-no. We cannot have that. So transfer everything in the numerator over, rationalizing it. We're going to shove it and leave it. Shove that square root of 3 up top and leave the 3 on bottom, the radicand on bottom by itself. When we take a look at the whole numbers, 8 over 3, we cannot simplify that fraction. So we're going to leave it as 8 square root of 3 over 3. The square root of 3 and 3 are apples and oranges. You cannot divide those. You cannot simplify those. Okay? Now to find Ln, now that we know what A is equal to, Ln, the hypotenuse, is 2A. So again, A is going to be the 8 square root of 3 over 3. What we're going to do is we're going to remove that A, okay? And we're going to plug in that 8 square root of 3 over 3. Noting that the 2 is a whole number, 8 is a whole number, okay? We're going to be multiplying fractions now, so let's see what happens here. Let's make 2 into a fraction, put it over 1. When we multiply fractions, you learned in junior high that you multiply straight across. So when we multiply straight across on top, we get that 2 times the 8, gives us 16. The radical has nothing to do. We just bring it over. And then that 1 times 3 just leaves it at 3. We're still seeing here that 16 over 3, we cannot simplify that, so we are done. All right, next. label everything. Here's our 90, our 60, we have our other 30. Across from 30 is a, across from 60, a square root of 3, across from our 90 is 2a. These are the two that are equal. That's how we're going to solve for a. Okay? So mn is a, so we're going to find that one first. So let's go look at how to find mn. We set 2a equal to 4 square root of 3. And we need to get rid of the 2 in front of the a. So just as if it was 2x equals 4, okay? We're going to divide both sides by that 2. So the 2's cancel. And all we have left is that a. But here we also need to see that we can simplify this. So this becomes, move it down here, 2 square root of 3. Done. 4 divided by 2 gives me 2. Bring that radical over. We're down right here. 2 square root of 3. Now to find LM, okay, our other leg, let's take a look at what we do here. LM, as we know, is a square root of 3. So we're going to take out a. We have square root of 3. Took out a. We're going to substitute in what a was. Remember, the 2 square root of 3 is what we found a was. Okay? So we need to substitute it in. Put it in parentheses. We have 2 square root of 3 times the square root of 3. We have radicals to multiply. 2, we can't do anything with it. No other whole number. Then when you multiply the square root of 3 times the square root of 3, you get the square root of 9. Pay attention. This is why you need your perfect squares memorized. You can simplify the square root of 9, and it becomes, I know I addressed this with several classes on the 45, 45, 90. What ends up happening here, bring over the 2, this is a multiplication. 2 times the square root of 9. When we take the square root of 9, we're going to get 3, not the square root of 3. A whole number 3. I had several students saying, oh, the square root of 4 was the square root of 2. No, the radical is gone. Once you have a perfect square, it becomes a whole number. And so with that being said, remember it's a multiplying, okay? So here we wind up with the final answer of 6. The last problem, we're going to use this triangle. We're going to, the length of one side, okay? So the length of one side is 11 centimeters. So we have 11 over here. We're going to find the altitude. The altitude, remember, is this segment right here, creating at 90 degrees. So we can ignore one of our triangles over here. Up top, where the altitude came out of, is your 30 degrees. And then your 60 degrees over here. It's what we talked about right here on the front page, right here. Okay? So if you want to see that triangle separated, to make it a little bit easier, please draw it to the side. Okay? We have the 30 up top, the 90 on the bottom left, and 60 on the bottom right. So we'll go ahead and label everything we know here. Across from our 30 is a. Across from the 60 is a square root of 3. And across from the 90 is 2a. They gave us the side length of 11. So this is 11 over here. Circle what we know. We know that 2a is 11. Okay? So we're going to set 2a equal to 11. To get rid of the 2, we divide both sides by 2. Now, a is going to wind up being 11 over 2. We've discussed, and I discussed in my classes, that we're not going to simplify this into a decimal because when we have our radicals, we don't want a decimal in front of that radical. Okay? So we're going to use 11 over 2 as a. So to find the altitude, the a square root of 3, okay, again, we're going to remove a, and we're going to substitute in for a, which is going to be 11 over 2. And this is a multiplication. So we're going to make that square root of 3 a fraction, just like we do with a whole number. You just put a 1 underneath it. And then, like we discussed earlier with fractions, you simply multiply straight across. Well, the 11 and the square root of 3, it's apples and oranges. We can't actually physically multiply them, so we just put them right next to each other as 11 square root of 3. And this is all over 2 times 1, 2. Looking at 11 square root of 3 over 2, cover up that radical, 11 over 2, we cannot simplify. Okay, so we just leave it as 11 square root of 3 over 2. There are a few little shortcuts down here that you can memorize to help you out with exactly what to do depending on what you have and what you're looking for. Okay, I don't want to use too much time on the video, but you can read through that and see if that helps you out at all. Okay, but if not, then just do what we've been doing in the notes. Okay.